Hi, welcome to Nursing School Explained. This is the second video of the EKG interpretation series and my new playlist. This video specifically will go into how to look at the EKG paper and what it tells us about the time and the amplitude of the impulse, as well as how to determine the heart rate in a very easy way. If you haven't already done so, I highly recommend that you watch the video about basic electrophysiology, where I review the principles of depolarization and repolarization and apply them to the PQRST waves of the EKG. So the EKG paper, if you've seen it before, there are a lot of different boxes on there. And these boxes help us to measure the amplitude or the electrical impulse as well as time. So here on the x-axis we have time, and on the y-axis the amplitude or electrical impulse. If you look over here in terms of the amplitude, we have one small box here represents 0.5 millivolts, and that is regarding the force of the contraction and the amplitude of that electrical impulse as it travels through the heart from the SA to the AV node to the bundle branches and then up the Purkinje fibers. And then secondly, probably the more important part of the EKG strips is to know the times that these boxes represent. So let's start by looking at these bigger boxes. Up here you see these lines, and that means between each one of these bigger lines here we have 3 seconds, which means that from the beginning to the end here, which are 2 of those 3-second increments, we have a total of 6-second interval. And that is very important because most rhythm strips are printed in a 6-second strip, and then this is what you use to calculate the heart rate as well as look at for determining the rhythm. And we'll go into how to determine the heart rate here in a bit. Now, looking at these smaller boxes here, so one of these represents 0.2 seconds. And that is important to know in terms of the different intervals, because certain intervals of the EKG are supposed to last a certain period of time, and if they don't, then we know what kind of dysrhythmia that we might be dealing with. This here is another view or another picture of the EKG paper. So again, we have 5 of these small boxes representing 1 second, where one of these smaller boxes is 0.20 seconds. And then if we cut out one of the small boxes, one slice here, this will be 1/5 of the 0.2 seconds, which is the 0.04 seconds. Again, looking at it over here, 1 second is 5 of these smaller boxes. One large box is 0.20 seconds, and then 1/5 of that, so one of these small boxes represents the 0.04 seconds, just like over here. So these are the same. And mostly we'll be looking at the PR interval and the QRS segment because they're supposed to be discharging in a certain period of time, and knowing how many seconds these boxes represent will let us determine how long the different intervals are, and then we can determine if and what dysrhythmia that we're dealing with. So looking at determination of the heart rate, we just talked about that most strips are 6-second strips. And here again, we have those 3-second marks. On this example, they're not very big. So if we have these 3-second marks, we have basically 2 of these sections. So that again means that we are looking at a 6-second strip. Now on a 6-second strip, we have to measure the QRS wave. And we basically just look at the R wave of the QRS complex. So we count those. So 1, 2, 3, 4, 5, 6, 7. So we have 7 QRS complexes in 6 seconds. So if we multiply that by 10, 6 seconds times 10 gives us 60 seconds, which is 1 minute. And then 7 QRS complexes, we multiply that by 10 as well, which gives us 70 beats per minute in 60 seconds, or 70 beats in 60 seconds, which gives us 70 beats per minute. And this is really the easiest way to calculating the heart rate. Of course, now if the heart rate gets irregular or there is a pause, for example, for some reason, the dysrhythmia includes a pause or something else is going on with the conduction system, the rate might not be regular, so this calculation might be off, which is when you might need to look at a little bit of a bigger strip, maybe a 12-second or 18 or 24-second strip to get a better understanding. But if when in doubt, then you would always get a 12-lead EKG anyway and not just a quick telemetry printout. So looking at this next slide, this is another representation of the different boxes here. So again, the smallest box is 0.04 seconds. 2 of those would be 0.08. 3 of them 0.12. 4 of them 0.16. 5 of them 0.20. And then 5 of those bigger boxes in this case would be 1 entire second. And then over here again we have the normal EKG with our P, Q, R, S, and T waves. And what we'll mostly be looking at is the PRI or the PR interval and the QRS complex. Remember that the P wave represents atrial depolarization, and then the QRS complex represents ventricular depolarization. And the PRI is basically measured from the beginning of the P to the beginning of the R. So right here where the Q happens, where the upslope is the beginning of the R. So this is our PRI, PR interval. And then the QRS segment is from the bottom here, from when the Q wave starts, including the R, and then all the way until the S wave returns to the J point right here. The J point is the junction point where the QRS complex and the ST segment meet. And the J point is very important to look at because there is something called the isoelectric line. And that is this line that starts out right here and then continues very straight. And my line here is not very straight, but you can see this line starts here and then comes exactly back to the same amplitude, to the same height here. And looking at the J point is super important because when we're looking at this ST segment is when we're looking at ventricular damage or ischemia or infarction, which I'll be explaining a little bit more in the following video. And so this J point is here when the S segment returns back to this isoelectric line. Now, if this S segment was going to come all the way up here and then go into the T wave, then we would have ST elevation. And if the S segment doesn't go down, but doesn't go up, but actually stays down here and then goes up into the T wave, then this would mean ST depression. But watch the next video for a more detailed explanation about that. And then the other important interval here we're looking at is the QT, which is from the beginning of the Q to the end of the T wave. And the QT interval represents the entire length of the ventricular activity, including depolarization and repolarization. So this is also measured because remember certain medications can prolong the QT interval, And so when the patient is on this medication, we have to look at that on their rhythm strip and make sure that the QT interval is normal. Next, we'll look at how to determine if the heart rate is regular. There are basically two different methods. One of them is to use a tool called the calipers, which you can see over here on this picture on the left side. And this tool has these two pointy tips here. And so you would measure, you can either measure the P to P interval or the R to R. The R to R is usually a little bit easier because the R wave is up there and it's easier to measure. So you basically put one pointy tip of the calipers in this R, and then the other one over here on this R wave, and then you would flip this side over to the next one and see if the distance remains the same. And then you know if the heart rate is regular, or of course if it's irregular. Now the other not so fancy method is the mark your paper method, which you don't need any tools, you just need a blank piece of paper. And so you have your rhythm strip right here on the top, and then what I've done here is I've taken a simple piece of paper on the second picture, and I've marked with a pencil right here where the R waves line up. So this white paper here is obscuring part of this rhythm strip here, so the white paper is kind of lined up right there. And then what I did, I've marked these R2R complexes, and then simply I've just moved the paper over to the right. And if these lines here line up with the R segments, that means that they're the same length and that the rate is regular. Here is some credits and rhythm strips, also other good resources for you to look at. So please also watch my video in the EKG interpretation playlist that includes basic electrophysiology. The next video will be EKG interpretation, the basics, looking at normal intervals, and then rules to memorize. Now those rules are really important because if you apply them the same every time that you're looking at the rhythm strips and you memorize these rules, you will do really well on interpreting dysrhythmias. And then we'll look into different rhythms, which will include sinus rhythms, atrial rhythms, atrioventricular rhythms, as well as ventricular dysrhythmias. So thank you for watching Nursing School Explained. Please also check out the other videos in my EKG interpretation playlist. Leave me comments, share and subscribe, and I'll see you again soon. Thanks for watching.